Alright, so the next thing I need to talk about, we've tested the soil moisture sensor and we got the Arduino to read it, and we want to do something based on that meaningful. Well, the next thing to do is add water when it's dry. So that's where this sucker comes in. This is one of the best things that I have found, and I just got it on Amazon, and all it is a little USB powered water pump. Now, it doesn't flow a lot of water, but for something like this it works perfect. But the thing is, how is this going to work with this? Well, luckily I have some of these, just standard USB female board connectors. Soldered some little jumper wires onto it using standard USB protocol. Power and ground are on the outsides. So when you're in doubt about the connections, a quick Google search, honestly, USB pinouts, you'll find this, and it'll give you the information you need. If I remember correctly, this is the ground and this is the positive, standard USB protocol. So I'm going to hook it up that way, and we're going to see if this sucker makes noise. So I've got 5 volts on my power supply, and I connect it. Well, I don't hear it doing anything, but when I did it, my power supply grounded out. It's actually drawing more current, and so my power supply is current limiting, so it's not providing enough current, so the voltage is actually dropping down is what's happening. So I'm going to do that and increase my current, and it started working. I don't want to run it too long because there's no pressure. I could wear it out by doing that, but what we will do, alright, so the water is steel-ish. Get all the air bubbles out. So you can hear it. You can see it moving the water. It's a running. So what I'm going to do is I'm going to adjust this flow setting, that way you can actually see it. This way, all it does is open a little valve. It'll take in more water. So I'm hoping it'll spray a little bit. Hopefully we don't make a mess. All right. There you go. You can actually see it spraying up. This thing will move some water. So our pump works, but the Arduino isn't going to supply that. So I've got to add in extra circuitry to provide the power supply directly to this, but it means that the Arduino can control. So that's our next step. So to work as a switch, I like these little suckers. So let's see if we can get it to pop up here. There you go. IRF740 NMOS transistor FET transistor. Yeah, like I said, we could use a little BJT, but this will handle more power. If I remember correctly, this thing is about 1 or 2 amps. That's a lot more than we ever plan on using. Plus it's got the nice heat sink on it, so we don't have to worry about it overheating even in a hot climate. So we're going to use these suckers. So what I'm going to do here, teach you a little something. IRF7, look at there. See, Google knows me and Google knows stuff. 740 NMOS. This should be a skill right here that everyone needs. We want to look at a data sheet. So always check where you're going. Don't just click the top one. Viz-A, They're a component manufacturer. Most use a standard set. Every now and then you'll find some where the gate terminals are reversed. But this is what we need. The gate here, we've got the drain and the source. This is all the information we need to properly connect this. So our pertinent information there. Alright, so I've been fiddling around trying to figure out what the issues were with turning the pump on and off. So the first thing I did is I checked here, and I know I'd hastily put it together. It worked, but it wasn't a sound setup. So I fooled around. I've got a pull down resistor that'll, when I disconnect, will bring my signal back to low, and that way it doesn't ride high. I was having a problem with it latching, and so that's where we were at. So it's fixed now. I moved the pump to the high side of the gate, and it seems to be working pretty good in my testing. So I've reconnected it, and I've gone back to the Arduino, and it's just it's still not working. I didn't know what was going on here, so I decided to do some testing. I went and tested, and here's what I found out. If you watch the multimeter, so if I check the pin we're on, which is what digital 2 should be, we get nothing. But looking around, I found this one doing exactly what I expected it to do, or what I programmed it to do: a second high, a second low. And you see, we're not even getting the full 5 volts out, which is a little disconcerting to me. But this one is labeled as A6. It is way off, and so I don't know if that's an issue with the libraries or if it's an issue with the resources. Either way, it seems to be an Arduino thing, because this is made by Arduino, and the libraries that I'm using are made by Arduino. Okay, so I got it figured out. The issue with the Arduino pan is it's been so long since I've worked on Arduinos that I forgot about proper protocol. So I was wanting to use D2, and when I was looking at the pinout, originally the information I had, it actually gave me pin number from the chip, and D2 is pin 20 on the chip, but that's not how Arduino looks at the numbers in the IDE. So when I was doing the digital write here to pin 20, it was actually doing digital 20, and I forgot about this. So since I wanted D2, all I had to do is call 2. So if you look back over here, I'm now connected to the digital pin 2 that I wanted, but that still didn't provide a full 5 volts. It only goes to about 3.9, I think it is. If we come over here and look, we can find out. And I'm covering it up. Well, the circuit doesn't allow it to go all the way up. It's pulling it down, or at least what I currently have. So what I have here is I still have the transistor. I moved the resistor from pull down to pull up to 5 volts. That way I'm not pulling from this reference voltage. And so now whenever this signal goes low, it then grounds out here and turns it off. When it goes high, this transistor turns off, and so it starts to float high, and so we get a high signal on the gate, and that's really what's causing it to go on off. So I made a little change to the code. Let's bring this over here so you can see we're running. All I did was add an if statement. So after I do my soil read, I give it a chance. If the soil value is greater than 200, it turns the pump off. That means if there's moisture, because if you remember, when we get full connectivity, this reads a full 5 volts. So it turns the pump off. Else, that means if it's 200 or less, we set it to low, which turns the pump on. So as you can see, we're not touching, there's no connectivity right now, so the pump is running. But, and you can see there on our serial print that I'm getting full 5 volts. So here's me, I'm the soil. There's a little bit of resistivity, so we get a voltage difference, but it's only a small amount. So it sees it as wet at this current reading. Now this is where fine tuning is going to come into play. We'll have to, this number varies with soil types. Certain soil types you're going to need a higher number before you want it to turn off. You want it to fully saturate. If you have a high clay content, it's going to take a while. You're going to have to let it run longer, most likely. If you have soil that doesn't drain well, you're going to have to turn it on, and it's kind of constantly just going to be turning on, turning off, turning on, turning off. But soils that drain really, really well, you might have to run it longer, and so therefore you have to get a higher value, closer to your 700 or 800. You see it's reading 500. Is that what it's saying? Yeah, 600 for me holding it, and I wouldn't say that I represent a good moist soil, so we're probably gonna have to increase that value, but we'll have to play with it. It shows that we're working. That's all we're worried about right now.